So yesterday we were discussing, computer-aided programming. And am I audible? Hello,
Yes,
hello.
yes.
Screen also is also visible, no? So what is APT characteristics? And there are basically four types of statements. That is geometry, motion, post-processor, and auxiliary statements. And we saw uh, geometry statements. And in geometry statements, we saw how to define the points. There are various ways of defining the points, right? And then these are different ways, but out of which the most comfortable and the most safest is defining the points in x, y, and z, even though there are many methods to define the point. So you can define the points by pattern. There are various type of patterns. Mm. Then we also saw how to define the lines. Again there are many ways to define the lines. So line, the most common way is the line passing through the point P1 and P2. So although there are different ways of defining the lines, the most comfortable is line passing through the point 1 and point 2. So there are different methods how to find the lines. The lines can be defined by the slope, can be defined by the value, hmm, intersection, modifier. Then now line is passing to the point 51, and it is on the left hand side, and it is tangent to the circle 11. Because from a outside point there can be two lines which can be drawn as a tangent to the circle. So sometimes it depends upon the drawing, how in the drawing how the dimensions are given. Like here, uh, the lines are drawn at an angle. Mm. Here, lines are defined by slope. Here, again, at an angle, but with respect to the first line. With respect to the first line. So if you don't want to calculate, then you can go this command. And if you take little more pens to calculate, then you can simply calculate the points, and you can define the line passing through the 2 points. And as I said, the angles are always measured in positive sense in counterclockwise dimensions with respect to the x-axis. Now here this is a point. So from this point you can draw two lines tangent to the circle. Hmm. So but if I am particularly interested in this line, then how do I define the line? That line 1, that is L1, it is passing to the point 51. It is on the left hand side. It is tangent to the circle 11. So now here you have to remember the circle 11 you have to define first. At the same time, you need to define the point 51, point 51, or point 51 or point 1, whatever it may be. Yeah, Renan, is it clear? Did you join just now, Renan?
No, sir, I
Hello?
joined before.
So is it clear that line what I was telling that tangent? Hello.
Yes, sir.
Yeah, Renan. Is it clear? Yeah, that is,
Clear.
there can be two lines, but out of which we want this. So this is and tangent is 1. So in this case, if you want to define the line like this, then in this case, it is necessary that you have to define the point 51 and you have to define the circle 11 first, right? Shall I go ahead, Renan?
Yes, sir.
Yeah. Hmm. Again, now see. This indicates how to define the left and right direction. Like suppose if you are standing here and if you are talking about point 51, okay, so the left is this and the right is this. Or if you're standing here point P, so you have to view in this direction, you have to look into this direction. So left is this and right is this. Hmm. That is, you have to stand here, assume that you are standing here and you are looking towards the circles. So this line will fall on the left hand side, this line will fall on the right hand side. And this is tangent to C3. Here you are considering the top view. Hmm. And this will be on the right hand side. And similarly, line 7. So you have line 7 now. It is like this, line 7. So it is on the left hand side of C3 and right hand side of C4. Left hand of C3 and right hand side of C4. Or there can be other way also. That is line number 7. It is on the left hand side. It is tangent to C4. All right. It is on the left hand side and this is on the right hand side. All right. It is not that difficult. Similarly, now here line 8. So line 8, it is on the right hand side of the circle C3. Line 8. It is on the right hand side of the circle C3 and it is on the left hand side and tangent to the C4. All right, I'll just give you time to settle down. Just have a look. It's not that difficult. Now line L9. Again, it can be defined by two ways. That is right tangent to C3. Where is your line L9? L9. I am talking about this line. Have a close look. Yes, Renan, is it clear? Line L9. Hello, Renan.
Yes, sir.
Hello. Yeah.
Sir, can
See
you
now
repeat?
this is line L9. Yeah, a line L9, that is this what I'm telling, that there are two ways that line L9 can be drawn. See, this is what line L9 is. So it is right hand and it is tangent. It is on the right side to circle C3, tangent to circle C3, and it is on the right side and tangent to the circle C4. And if you look in this direction, then it will be on the left hand side. That is, if you look in this direction, then it will be on the left hand side, tangent to the C4, and left hand side, tangent to the C3. So it depends which directions you are viewing, whether you are looking from here or whether you are looking from here. Hmm. The convention is you have to look from left to the right. Like suppose a spindle is a simple example. Suppose a spindle, a shaft is rotating. Consider a shaft is rotating. This is a shaft and it is rotating. It is rotating towards you, means it is rotating like this. Suppose it is rotating like this. So if you look from this direction, if you look from this direction, you will see that it is in the anti-clockwise direction. But if you look from this direction, you will see that clockwise direction. So the convention here for APT program is from left to right. Then is it clear the example which I give you, shaft ka rotation of the shaft, or you want me to repeat?
Yeah, sir. Just repeat it once again.
Yeah, shaft rotation, that is shaft is rotating. So if, and you are standing here and shaft is rotating towards you. So if you look in this direction from the right hand side, it is rotating in counterclockwise direction. And if you look from this direction, यहाँ से देखेंगे तो it will see that it is rotating in. Am I right, Renan?
Yes, sir.
So again now another ways of defining the line. This is your line 3. So it is parallel to line 15. Now there can be infinite number of lines which can be drawn to line 15 and which are parallel to the 15. There can be many number of lines. Now if you are talking about this only one this particular line, then you need to define some points. So we can say line 3 which is parallel to line 15 and it is passing through point 6. Passing through point 6. So now this line is constrained. This line is constrained. Again now suppose this is the line 4. Alright. So line 4 is perpendicular to line 13. Now there can be number of lines which will be perpendicular to the line 13. There can be number of lines. So if you are talking about one particular line, then you can say that line 4 is perpendicular to the line 13 and it is passing to the point 5. So now this line is constrained. Hmm. You have to always see that you have to define the entities. Entities means points, lines, circles in such a way that it is constrained. If you simply say that line 4 is perpendicular to line 13, then you will not get the desired line because there can be infinite number of lines. Now another is here now line 5, it is this, hmm, and it is a line which is passing to the intersection of plane 1 and plane 2. Okay, so it is totally constrained. This line is totally constrained. It is line 5, hmm, is passing to the intersection of plane 1 and plane 2. So these were the various ways of defining the line. So we have seen how to define the points. We have seen how to define the lines. Now we'll see how to define the plane. And all of you know that if there is a single point, then there can be infinite number of planes passing to that point. Again, if there are 2 points, there can be infinite number of planes passing to that point. But if there are 3 points, there will be only one plane. If there are 3 points, then there will be only one plane passing through 3 points. There can be only one line, one plane passing through the 3 points. So we will again see the various ways, of describing the planes. And as I have been telling that you have to select the simplest way. Simplest way. Don't select the complicated way. If required, you can calculate. You can do some calculations offhand. Hmm. So now here plane 10 is to be this is the plane which is to be defined plane 10, because sometimes what happens, you can do machining in one plane, you can do machining in other plane. So now plane 10 is a plane and it is passing through point 6, point 12 and point 15. All right, simple. So I have these 3 points. So now this particular plane number 10 is completely constrained, because through these 3 points only one plane can be pass. Sahil is not seen nowadays. Are you there, Sahil? He's not well or what? Sahil. Anybody has idea? Your CR Upkar. Any idea about Sahil? Where is he?
No, sir.
No. But he is available on the group, no? You don't have conversation with him telephonically or
Sir,
on the
he is
group.
available. Yes.
Yeah, he's available, no? But I think last few lectures I am missing him. Just pass message.
Okay, sir.
Uh, So uh, now this is a plane. Now another way of defining the plane. Now this is a plane 14. This is what we are defining, isn't it? Now this plane we have already defined this plane. Plane number 10 has been already defined. Now how to define this plane 14? So plane 14, it is a plane, alright, it is parallel to this plane 10 with the previous entities. So you have to see that previous entity is defined. So now in this case, plane 10 is already defined. Now y small 3.0, right? Y small 3.0. So that means this plane number 14, it is parallel to this plane 10, mm, and y small 3.0. Now if it is parallel, so again there can be many planes, isn't it? Parallel to this plane 10. So it can be, now if I say 3, so 3 it can be here or it can be up also. So now which is the smaller distance? That is, suppose if I am talking about this x0 y0 z0, if this is my 0 point, then obviously the smaller side is this and larger side is this. So definitely this plane 14 it will be defined over here and not here. So that's why you need to define this small. Hmm. So we have seen points, we have seen line, we have seen plane. Now let us see circle. Now this is the simplest way of defining the circle. So circle, it is passing through a point. So either you can define this point P1 as say 3 comma 6 comma 5, simply write the coordinates here, 3 comma 6 comma 5, and then mention the radius. Now radius here is 4.3, and remember this sequence is important. This order is important. 3 comma 6 comma 5, uh, because this will be considered as x, then y, and then followed by the radius. Or another way is you can say circle and then center, that is say point 0.3, which has been defined already, and radius 4.3. So that's another way of defining the circle. Then next is, now we are defining the circle. We are checking the different ways of defining the circle. So circle C3, look at this now. Circle C3. If required, you can draw this. Here there are two ways of drawing the circle. That is a circle C3. So it is a circle. It has a center at point 0.6. Now remember, the point 0.6 is already defined, and it is tangent to line 4. Okay. So now tangent to line 4, there can be many circles tangent to line 4. Infinite number of circles, isn't it? These here, 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 here. Similarly here, 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 here. But when give a definite point number 6 as a center, then there will be only one circle. Hmm. There will be only one circle. It cannot be here, that is on the right hand side. It cannot be here on the left hand side, because we have said this is the center and radius is not required. Why? Because we have said that this circle is a tangent to the line 4. It cannot be on this side also, because the center of this circle is defined by point 0.6. Similarly, this now C7, that is a circle passing through point 0.5. It is passing point 0.5 and having a center point 0.8. So there can be only one circle which will have the center as point 0.8 and passing through point 0.5. So both these circles are constrained. Hmm. Then next, just have a look here. Hmm. This is a bit complicated, but you will be able to understand it. So I hope you understood it. So we are trying to draw the circle C3 here. Circle C3. So circle C3, it is a circle, and the center, you know, this is the center. Y large, line 6, then X large, and then line 4 and radius 2. Because this circle, there are 4 circles, but out of which I want this circle. Remember, see, there can be 4 circles, that is one circle here, another circle here, and one more circle here. But I want this circle, isn't it? So how to define this circle? Okay. So this circle can be defined in this way. So you have to select now the largest for this, you have X for this, you have X for this, and you have X for this. Okay, so you have to select X large. Hmm. If I want, this circle X large. Okay, then you have to select Y small, and then you have to select the line and then radius. But nobody goes, for such a complicated manner, because there are chances that you may make mistake. So it is always advisable that you calculate the center, where the center is located, and just define that point. So again, this is here, there are chances that you may make mistakes. So it is always advisable that you define a point, define a circle, okay, circle center, and give the radius. So that is the safest way. This is the safest way of defining the circle. Now here there are, series of holes. So this is an example for geometry. So now here there are points, one, 2, 3, 4, 5, 6. Then there are holes. Okay, then there is an arc. Hmm. So how to define the geometry? Now remember here, first thing is that all the dimensions are in inches. All the dimensions are in inches. Like say this is 4 inch, this is 5 inch. Just have a look on this. Yes, so I think you understood this example. So remember, all these dimensions are in inches. All these dimensions are in inches. This is like 1 inch, 1 inch, 1 inch, 1 inch. Then this is at zero point 0.7, zero point 0.7 inch, zero point 0.4 inch, then 4 inch. Now start of this arc is at a distance of 5 inch. So this circle is tangent, and this line is tangent to this circle. Mm. And the thickness of the workpiece is half inch, that is 0.5 inch. So this is actually not a side view, this is front view, and this is your top view. So there is a mistake here. This is a front view and this is a top view, or this can be front view and this is a top view. Hmm. So how we will define now point 1? So before you describe all the geometry points, you need to give the 0 points. You need to give the 0 points. So in this particular example, this is x0, y0 is here, and z0 is here at this level. So z0 is here, and x0, y0 is here. So this is must. This is must. Defining the program 0 point. I have been always telling you that you must show where is your x0, y0, z0 is, and it is at the discretion of the programmer. So programmer can give it here, can give it here, anywhere. And z0 is usually at the top face. z0 is usually at the top face. So this is the simplest way of a geometry example. So point 1, you can define by pattern, you can define by command called as the array, huh? But that much advanced learning is not required, hmm? Because we have ready-made softwares wherein we get the ready programs. Only we should be able to understand the programs. Even if you are not able to write the program, the most important thing is that you should be able to understand the program. So now here point 1, that is, it is a point. So PT1, it is a point, and x, y, and z. See, x distance is 4 inch. Where is your point 1? Point 1, point 1, point 1, kahan pe hai? Hmm. So this is your point 1, 450. So which is nothing but the your reference point. And your x0, y0, z0 is here. That means in this case, your program 0 point is this. So with respect to this, I think it is not to the scale. With respect to this point, in x direction it is 4 inch, in y direction it is 5 inch, and then it is at this surface, at this top surface. Then point 2, that is this. So point 2, it is at a distance of 5 inch in x direction, at a distance of 4.6 in y direction. See, it is at a lower height than this. That is 4.6, and then all this z in this, so that is z0 at this face. So that is 5, then 4.6, then point 3 is here. That is, it is a point, and x distance is 8. X distance is 8. So this is 4, then 5. This is 4. X is 4. X is 5. X is 6. X is 7, and X is 8 inch. And Y is at a distance of 4.6. Alright. Then so point 1, point 2, point 3, point 4, huh? And where is the point 5? So point 5 is this, which is nothing but the center of this arc. Center of this arc. So point 5 is equal to, it is a point and it is at a distance of 9 inches in x direction, and in when it is at a distance of 3.75, that is, this is what is your y direction is, so it is 3.75. So now once you are defined this point, it is easy to define this circle. So this circle can be defined as center, I say. Hmm. So this is your point 5, then C1. So now once you have defined all the points, then you can define the C1. It is not necessary that all the points should be together or all the circles should be. You can define anyhow, but you have to see that before you define C1, now C1 requires point 0.5. So point 0.5 should be before C1. That care you have to take. That is what is must. So now C1 is nothing but a circle, alright, and center is this. Center is zero point 0.5 and radius is 1.25. Okay. So radius 1.25. Then we are defining point 0.6. We are defining point 0.6. So point 0.6 is, where is your point 0.6? Point 0.6. Point 0.6 is this. So it is at a distance of 4 inch in x direction, 1 inch in y direction, and at this level. Hmm. Then L1. So you will understand why we have defined point 0.6. So now L1. So L1, how it is defined? It is line. Okay. It is passing through point P1. Okay. Now there can be infinite number of lines passing through point P1. So we need to constrain it. So what we say, it is left hand side on this circle and it is tangent to this circle. So we say tan to C1 and it is on the left hand side. It is on the left hand side of this circle. So tangent to C1 and left hand side of this circle. Alright. Another way is you can define this line passing through the 2 points. But for that you need to calculate this point. That is this tangent point you need to calculate. If you have calculated this point, then you can simply, and if you name this point as say point 10, then you can simply say L1, it is a line passing through point 1 comma point 10. Simple, most simple. But in that case you need to calculate this point. Now C1 is nothing but a circle having center at point 0.5 and radius as 1.25. Then you have point 0.6, that is this, that is equal to, it is point having coordinates as 4 comma 1 comma 0. Then you have line, then L1. Okay, we already defined this. Then you have line L3. It is again not necessary that L2 should come before L3, not necessary. So now you have line L3. So L3 is a line passing through point P1 and point 0.6. So that is this. Okay. So this is the simplest way of defining the line. Then you have line L2 which is passing through point 0.6. Okay. And you can simply say it is tangent to this circle and it is on the right hand side of this C1, right hand side of this C1. So that is on the, because from this point there can be two lines tangent to this circle. One is here and another is here. Obviously this will be on the left hand side and this will be on the right hand side. Another way is that you calculate this tangent point using your basic maths, trigonometry, mm, and you can define that line L2 passing to this point and this point. But since you want to, or we want to avoid the calculation, we are saying that it is tangent. Then now plane. Okay. So we are defining two planes. So one plane is this plane one, and another plane is this. That is the bottom of the workpiece. Yes. So we say plane one. So it is a plane and minimum 3 points are required. So we say plane one. It is a plane passing through point one, point two, and point three. Is passing through point one, point two, and point three. So your plane is defined. Then you can say plane two, plane two. So it is a plane two. It is a plane which is parallel. Plane two. It is parallel to plane one. That is this plane. Okay, linear, linear, and z small. So this is a smaller distance, which is at a distance of zero point 0.5. So you can define plane 2 very easily. Now there are two ways, that is either you define all these holes with the coordinates, or you can define a pattern. You can define a pattern. So we say pattern 1. So pattern 1 is a pattern linear uh, passing through point 2, point 3. Okay, and in between you have four holes. Then we'll say pattern 2. hmm, So it is a pattern linear and passing through point 3 and point 4. So three holes. Okay. So one is this. Here we are defined four holes. Another is this, and here we are defined that there are three holes. Now what is your pattern 3? Pattern 3 is pattern that is copy. Copy pattern 2 on pattern 1. Copy pattern 2 on C. Copy pattern 2 on pattern 1. So you have already pattern 1, that is this. You have already pattern 2. So what you are saying, copy pattern 2, that is this, on pattern 1. So this will be copied on on this, on this, on this, and on this. That is, this pattern will be copied on this hole, on this hole, on this hole, and this hole. And this pattern consists of three holes. That means three holes here, three holes here, three holes here, three holes here. Hmm. So like that you will get all these three holes. Then these are now geometry statements are done. Okay. Then geometry statements consist of points, lines, circles, plane, uh, that is which are necessary to define your object or define your product. Now motion statement. So motion statement consists of again English high level language like from, go to, go delta, hmm, and this constitutes your machining plan. This constitute your machining plan. So what is it? So you have different statements like say from, go to, go delta, and so on. So we'll see one by one. Now again, this is a simple geometry, the simple geometry having say point P1, point P2, and point P3. Just have a look on this, try to understand this. So you have point P1, point P2, and point P3. Now your P0 is here, which is at a distance of 0, 4, point 1. Z0 is here. So point 1 means it will be at a distance of point 1 from this face in Z direction, and this point is at a distance of 0 and 4 inch. That means your program 0 point is somewhere else now, or your reference point is somewhere else. So now this is your, you can say that this is your program 0 point, and your reference point is somewhere at a distance of 0, at a distance of 4, and at a distance of minus point 1. So at a distance of minus 0, at a distance of minus 4, that will be here, and at a distance of minus point 1. I hope you are understanding this, what I'm saying. Hmm? Then you have something called as the macros. Huh? So first I will just tell you what is this from, go to, and go delta. Huh? Then we'll go ahead. So from means from which point you want to go. That is from point P1. That is from here to here. So from this point. So obviously from will be followed by 2. So from this point, then you say 2. Okay. So that 2 is nothing but go to. So from this point, go to. And then go delta. Go delta means you will go it in feed. You will go it in feed. Okay. You'll go it in feed. Okay. So you just draw this diagram and then we'll continue next time. Hmm?
त्याला बरं नाही ते डॉक्टरने नको सांगितलं दुपारचं. संध्याकाळी 2 तास बरं नसतं त्याला. आता मला डॉक्टर बघावं लागेल. त्याला कसं तर माहिती आहे ना सगळं. ज्योतिषकडे जाते आता 1:30 वाजता जाईल. ती असते ना 1:30 वाजेपर्यंत. बरी आहे.